Hello and welcome to our Rust Meetup Linz. We say hello to everybody who is watching us in the stream, and I say hello to my friend Stefan. Hi, Stefan.
Hi, everyone. Hello.
How are you?
As you might expect, given what day it is today, but I'm holding up. I'm doing all right.
Mm. We are currently in different times, and our thoughts are with all those people who suffer under the current situation we have here in Europe. Many of us haven't thought that it would be possible that we have a situation that we have right now here a few weeks ago, well, even a few days ago. We even considered canceling this meetup, but at the end we decided to go for it because currently, personally, many of us can't do anything. All we can do is prepare for a time where we can maybe really help on a personal level. So our thoughts are with all those people who suffer under the current circumstances. We hope that you are well, that you are safe, that you can watch us without worry from wherever you are. And we still hope, even given those difficult times, that you will spend a nice evening here with us at the Rostlitz meetup.
Yes, well said, Ran. I think the best that we can do right now is maybe get your mind off for a couple of hours before you return back to doom scrolling on Twitter or the local news. So let's try to enjoy the next couple of minutes as best as possible. And I also wish everyone who suffers from this to be safe, to be well, and to beat this all over soon.
Very well. I will share my screen with you and start the community news slide. As always, also today, we would like to kick off our meetup with some community news from the local community here in Linz and in Austria. This meetup is brought to you by our very own programming club, our coding club Linz, and we are very happy to host this Rust Linz meetup as we have been doing it for nearly 2 years. We have two very, very interesting guest speakers today. Daniel from Tauri Foundations and Sishan will talk about implementing runtime-agnostic async crates, and Daniel will talk to us about Tauri, what it is, what it can do, their experiences with Rust, and everything around Tauri. We are really looking forward to their speeches, and we say thank you very much that you take the time to speak to us today. We have a good Discord server community. It's a good way to keep in touch. So we invite everybody to join our Discord server. Here is the link. I will also copy it after the community news into the YouTube chat. So you can just click on it and join our community. If you have any questions surrounding Rust, or maybe you want to talk, you want to give a speech at Rust Meetup Linz, don't hesitate to get in contact with us through our Discord server. Now to the community news. The first one, I would like to present it to you myself. It's about the Coder Linz. Regular visitors of the Rust Linz Meetup know already about it. It's our weekly virtual programming club for kids between 7 or 8 and 17. The next online meeting is tomorrow, as every week, every Friday afternoon. We invite people, kids, to come to us independent of their knowledge, and they can learn how to code with Scratch or TypeScript or JavaScript. And we even have some Rust games prepared. I hope in the near future we will start to offer some Rust classes for young developers. So we are looking forward to that. I talked to the chairwoman of the Female Coders Linz. Their next study group is on March the 2nd. The 2nd, yes. The topic then will not be Rust, but it will be, I think, something around unit testing, JavaScript, or integration testing, something like this. Pretty interesting. So if you are a woman or a girl and you're currently learning how to write code, you want to enter the IT business, for instance, then Female Coders Linz are exactly the community where you might visit, and I'm pretty sure they have some interesting content for you. Next one is also one of our own events. It's the largest single event that we do every single year. It's the Global Azure Austria. It's called Azure, but essentially it's everything about cloud computing. Of course, Azure is an important part here. We currently have call for contributions open. Last year, we were so happy because we had Rust content, specific Rust content at our largest conference, and we would love to have some content there. So if you have any idea about some interesting topics about maybe Rust in the cloud in general or in Azure, then this is exactly the conference where we would like to hear from you. And we already have one of the speakers here in this call. Stefan, thank you for being there. And I guess that we will see at least a little bit of Rust in your talk,
Oh,
right?
there will be a lot of Rust. It will be a Rust talk. I'm really looking forward to this. So Global Azure Austria was always one of my most favorite events. Even back when it was still in person at the Wissensturm in Linz, it was always very lovely. And this is the first time that I'm doing Rust content at Global Azure. So I'm looking forward to this as well.
We need more. We need to make the Global Azure Rust. Let's put it that way. Okay, tomorrow is another interesting conference. Our friends from the Cloud User Group AT, they organize the Austrian Developer Community Day. It's a completely free, volunteer-driven, full-day community event with lots and lots of talks. I am afraid I don't think there is any Rust content there, but still they have a lot of great content. Maybe you run your Rust stuff in Kubernetes or Azure or any other cloud, and you want to learn about things like that. They have really interesting content, and you should definitely check it out. It will be tomorrow. It's completely free. It's from the community for the community. Okay, and Rustfest, I think, Stefan, traditionally you talk quickly about Rust.
Yes, traditionally I do. Actually, on Saturday, there's the Rustfest LATAM edition. That's for Latin America. There are about 5 talks and 1 artist. It starts on Saturday afternoon. So depending on what your schedule is on a Saturday, there might be plenty of time to tune in. And the European edition is in April or end of April. I guess there's already a date set, and the CFP for that is still open. The cool thing is I bought a ticket now. So I didn't buy a ticket yet, but I bought a ticket now. It's 50 euros for all events that run under the Rust First Global brand, which means that if you buy it now, you can access the late-term edition, but you also will get the link for the previous Rust in Arts edition, and the link is also valid for the upcoming European edition. So for $50, you get 3 conferences and lots of already recorded talks. So that might be something to look forward to.
I will definitely do that. Thank you. Thank you for pointing that out. And by the way, this is not a typo. The URL is really 2021. Although we have 2022, I think it's still under 2021. So I checked.
Exactly. It's the 2021 edition. Exactly.
Yeah. Okay. And with that, we would like to say thank you to our sponsor, Microsoft, and we would like for a few minutes get Jürgen up to the stage. Hi, Jürgen.
Hi, everyone.
Hi, Jürgen. Thank you for being with us, and we want to say thank you. You are our person from Microsoft here today, so our thank yous go to you. Microsoft is sponsoring our meetup, the next few meetups. We are a virtual meetup, but still we have some costs, like for instance, the StreamYard licenses and so on, and we need a little bit of financial contribution, and we say thank you to you. Jürgen, do you want to introduce you for quickly, please?
Yeah, thank you. Yeah, first of all, we're really happy that we can support you. It's a great community, and I also joined the last Rust meetup online, and this time is my second one. Yeah, it's really cool. I'm not a Rust pro at all, but it's really it's fantastic to see what the community is always coming up with. And a little bit of my background, you will find like contact information, all these kind of things on my public GitHub page. I also have a Twitter handle, but my let's say technical background is really on cloud native stuff. The cloud is where I run my workloads, so to say, or I used to run it, everything around Kubernetes. Right now it's more focused on Azure. But also a lot around the CNCF. So I'm also a maintainer of a CNCF open source project called Captain. I'm also certified on Kubernetes. I run together with Giuliano. I run a cloud native Linz meetup. It's an official CNCF meetup.
Speaking about that, I think there are news regarding the CNCF meetup, right?
Yes. So the CNCF meetup, they used to live on meetup.com, and we are now joining the official platform that is hosted by the CNCF for the community chapters. And we have now also the URL community.cncf.io/links. This is where we host now going forward our meetups. The first one on this new platform was actually yesterday. It was a fantastic experience. Everything works really well. But please, just as a reminder, if you have not joined us yet there, please join us there, because on meetup.com we might run out of the subscription, and then I don't know what actually happens.
I already did. So I already subscribed there. So everybody, shout out to the whole community here in Linz. Cloud Native Meetup. Register there so you don't miss one of your meetups. Jürgen, we would like to dedicate the last 3 minutes of our intro to you as a sponsor. You are now representing Microsoft, and Microsoft sponsors this meetup. So what do you want to tell us? What have you brought with you?
So there are 2 things that I would actually highlight. The first one, if you want to follow up on any of the resources that you see here on the screen, and I've also put together a link how to get started with Rust. There's actually kind of a reminder for myself as well. You will find the link here under the aka.ms link. I will post it also in the Discord, so you will have it for later on. And if you want to up-level your cloud skills or actually get started in the cloud, get some certifications, actually even win a Microsoft backpack, then we just started the Spring Skills Challenge. It's participation is for free. In this program, you also get the certifications for free. So it's a really cool way to kind of get started if you want to, if you're kind of early in your cloud challenge. And all these kind of things we usually also distribute on our Twitter, msdev_at. Yeah, it's here. I can also put it in the chat afterwards or in Discord. And just one last reminder, We also have a couple of interesting events. There are even more events, but I thought for this community, there might be two interesting ones. The first one, the Microsoft Cloud Native Summit at the end of March. But next week, in the morning, Wednesday morning, there is an exclusive update session on the Austrian cloud region. So Microsoft is also building a cloud region in Austria for our Austrian customers and also the community. So if you're interested in that, you're also welcome to join there.
That's very interesting.
From my sponsor hat.
Yeah.
So thanks for having me.
That's very good. Thank you very much. Thank you for supporting us. And looking forward to this Austrian cloud region info, because I'm very excited that we get a data center presence here from Microsoft really in Austria. Thank you very much, Jürgen. Thank you for being with us. And I hope you stay with us for another 1 hour or two. We'll learn a little bit, enhance your already basic Rust knowledge, and become a Rust pro in the upcoming hours.
Okay. Hopefully, I can do it within 2 hours to get to become a Rust pro.
We'll see. Okay, Jürgen, thank you very much. Thank you for being with us. Okay, and with that, I think we should get Daniel on the screen, on the stage. Hi, Daniel.
Hey, everybody. Hi, how are you doing? Hi.
We are how we are. Fine. Yeah, we are healthy. We are safe and healthy.
Doing
it's
all right.
Good. Yeah, to being able to say that. Hey, Daniel, where are you joining us from?
I am joining you all from the, well, still slightly overcast, but wonderfully warm Malta in the Mediterranean. So it's a direct flight to Vienna, I think, but it still would take you a couple hours to get here.
Mm-hmm. Ah, beautiful. So thank you for spending the evening with us. Daniel, you are today representing the project Tauri, and we are looking forward to hear a little bit about what this project is, what you do, what your experience is, what your relationship with Rust is. And yeah, with that, we would like to give you the stage. Do you want to share the screen with us?
Absolutely. Do I do that or do you?
Do you? You already do. Here we are. So I think technology now works. The stage belongs to you, Stefan, and I will now retreat and we will watch at home. We are continuously here. If you have any questions, either ask us or use the private chat. We are just one mouse click away.
Great.
Daniel, the stage is yours.
Right. Well, it's a hard day for a lot of people out there. And at Tauri, we've got a global community. So I think all of us are in some way directly or indirectly touched by the events. And I personally think, and I guess I can sort of speak for the core team at Tauri, because, you know, we all are pretty much aligned that in these kind of troubling times, the worst thing you can do is be paralyzed. And the worst thing that you can do is accept the status quo. And that's kind of the story of Tauri and how we got to, you know, where we are today. Our project has people talking about it on Hacker News and State of JS, and it's something that's just been growing over time. It's a kind of normal growth curve, I think. But I'm going to leave this chart up here for a second so I can talk a little bit about where we came from. Back in the summer of 2019, my friend and colleague Lucas and I were trying to find a better way to do things. We just weren't satisfied with Node, WebKit, Atom Shell, Electron. It always just seemed to be such a huge waste of resources. And I mean, we don't even want to talk about security yet, but we'll get to that. We looked at a lot of different languages to bind to web views. In fact, we used at the core the really amazing WebView library written by zSerge. Some of you might know that project. It was adopted by Boscop and wrapped into Rust. And basically, it's a bunch of C and C++ and a bit of Objective-C, and it has bindings to all of the system web views, which seemed like a great idea at the time. And, our very first proof of concept was written in Go, but then we did one in Rust, and I think we just loved the pain because back then we'd heard of Rust. Neither of us had used it. And we thought, well, the types of guarantees that you get are pretty exciting. And we both fell in love with the compiler messages. It just seemed that somebody had put a lot of thought and effort into making it an enjoyable experience, because I guess the worst thing that can happen is undefined behavior. I mean, okay, we're not going to get into the Rustnomicon and unsafe behavior. I'll talk a little bit about how we deal with unsafe later. But as time grew or passed, we started trending all of the time, and this grew our community. And we'll talk about community in a little while as well. It got to the point where, today, I took these screenshots today. So today we're in the top 300 projects on GitHub, and we're still in the throes of releasing our 1.0. I mean, our RC is just about to be released, and in the top 300 projects on GitHub, I guess there's like 18 million or something, but only 4 of them are written in Rust, or 5, excuse me. I think there's another one that we just edged out. But it's interesting to see that if you go down in the star charts to around 10,000, there's a lot more Rust, and Rust is definitely picking up in the library and the binary and the WASM industry. And I don't want to say that we are taking credit or we are riding the wave. I think for a lot of things, Rust makes a lot of sense, and that brings me to security. I guess one of the things we all have to recognize today is that we can't really trust any of our devices. If you've been following Twitter, you understand that there are already massive rootkits being spread around the Ukraine, and people are getting their data encrypted, and it's not a sign of the times. We've known about this for decades, and we claim to make smaller, faster, and more secure desktop applications, and we struggle with this misperception that there is ever a circumstance where security shouldn't be a concern. That's actually from one of the issues on our GitHub issue tracker. And I think that the problem with this perception is also fostered by the industry. When we as library and framework engineers push the tough decision-making about security to application developers, it's a hard and heavy lift, because the ease with which it is possible to make an application today means that you don't have to have a rigorous computer science degree. It means that, you might just be satisfying your own whimsy, or you might be working for a Fortune 500. And in both of those cases, I can tell you, there are sometimes bigger concerns than security, but we're here to tell you that there shouldn't be. And we don't want the software you make to become an attack vector that allows the bad guys to move laterally inside of people's computers or corporate networks. That's why we contracted out to Radically Open Security the job of horizontally and vertically auditing the Tauri code base. What that means is we had a logic audit. That's the horizontal one where all of the libraries were reviewed for soundness, for smell, for glaring security holes, and they found a lot of stuff. And this kind of raises the point that even if you have the best intentions, getting a second pair, third pair, fourth pair of eyes on the thing that you're building is really important. And since we're building a framework, it's doubly important. One of the recommendations that the auditors gave us is something that we're going to be returning to in the next months, and that is that we want to help people to employ more secure coding practices and provide tooling that gives you at compile time heads ups and allows you to integrate with your continuous integration pipeline to throw a non-zero error if one of your requirements hasn't been met. Just talking about the security aspects of Tauri would be, I don't know, probably a 45-minute introduction. But I also don't want you to just take my word for it. We are working on a very large body of documentation, and I'm just cherry picking a couple things here. So as you may know, Tauri uses a web view as the user interface and provides a Rust-based core backend. And we also provide an API by which the user interface can communicate with the core. So for example, let's say you just want to read a binary file and dump the contents into the user interface. Well, we do this with message passing. And so you would pass a message calling the API to the core. The core would then find that file if you've granted the application permissions to read that specific folder, and then return however you want to get that information back. I mean, if it's a JPEG, you could just, get the image back. Now, you might hear a lot of alarm bells going off in your head. Oh my gosh, unsafe JavaScript. And I have to tell you, the web is a hot steaming mess. The moment you are consuming any kind of third-party package, whether it's a node module, a Rust crate, or even a WASM blob, you're accepting that the person who wrote it is a good person, that they have your best interests at hand. And we know this isn't the case. In fact, you could also use a CDN to deliver JavaScript into your app, or who knows, you might actually render an entire website from Slack HQ or whatever into the web view. And the issue is not your code, because obviously you're doing a good job, but an attacker can, with enough pen testing, social engineering, GitHub reviewing, detect that you're calling certain APIs. Maybe they know that you've accept listed the entire body of APIs, and they want to read your etc shadow file. If you've permitted everything, then maybe it's possible for them to do that. And what the isolation pattern does is it provides a secure pathway so that only trusted code can call that API. Now, there's an entire write-up on this page. I encourage you to read about it if you're interested. But we're not just here to protect your users. I think that we can talk about security forever. As engineers living in a very, well, I wasn't prepared to say dangerous, but it is a dangerous world. A dying world is actually what I wanted to say. we all feel that it's absolutely relevant to take every step that we can to protect the environment. And if you're used to downloading normal applications for Linux, Windows, or Mac, you're used to things being several hundred megabytes. I think recently I saw that the VS Code project is about 500 megabytes. Slack is like 300. And I'm not picking on Electron here. Even native applications, so-called native applications coming directly from Mac, well, they also weigh in at 50 to 200 to even gigabytes in size. And so one of the things that we are constantly striving to do is reduce the size of Tauri applications. So obviously there's ways that you can strip binaries, and that last image was a Tauri Gulf project, a hello world without a JavaScript front-end framework that was then UPX binary compressed. And so it's not exactly a way that you would really do production binaries. In the field, if you're using Vue or React, you'll see an app size of about 3 megabytes. If you are really careful about, embedding fonts and applying all of the build time optimizations, 3 megabytes is pretty normal. And, it's similar for other applications using other systems, whether it's NWJS or Electron or WebView. 200 is pretty normal. When they ship an Electron app, for example, you're shipping a Chromium browser, you're shipping a Node runtime, you're shipping all of your JavaScript compressed as an ASAR. And for a long time that worked well. But this afternoon I spent more time than I would like to admit, but I spent a little time going through some typical scenarios for app life cycles. And so what you see here is, the download time for a single unit of an app. So if it's a Tauri app, it would be 3. A medium-sized app of 200 would take, it's 200 megabytes. That's, about 16 seconds to download on a normal 100 MBS system. And then we have the number of downloads. So, if it's a hobby app, you might get 1,000 downloads over time. If it's bigger, it might be 100,000. And if it's even bigger, well, if you're a very, 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 very successful app that's around for several years and you push out updates regularly, I can tell you that the 10 million number isn't actually very far away from reality, maybe on the short side. And then, you calculate the transit, how much, electricity you really consumed. And if you start really doing the math, like one big, very successful app produces enough CO2 that it would need 2,160,000 trees to be mature in order to remove the CO2 that they've produced. Hey, we can argue about, if it's 0.06 kilograms of CO2 or 0.1 kilowatts per hour per gigabyte. The point is that it's utterly relevant today that we start finding systems to do this for us. And I'm not going to lie, I cut my teeth on Electron and Cordova and these monolithic, massive apps because it was a great way to learn and to grow as a developer. But we feel that it's not exactly responsible. And one of the criticisms that we get is that we're using system web views that might not have the perfect layout on Mac as they do on Windows, and there's tons of problems on Linux. And I think that the community is okay with it. It might be a little bit more work to get it to be a little bit faster, a lot smaller, a bit more secure. And maybe it's not always. Is it not always? I mean, the criticism is that there's problems on WK WebKit on Mac and WebKit GTK, and there's CSS rendering problems, and it's not always the same on all platforms. But as someone who's been involved in the web for the better part of 2 decades, I can tell you it's always been that way on every browser. I mean, seriously, try to use Google Meets on Firefox, on Linux. I mean, come on. And so when we started this project, we knew that we weren't going to be able to do it alone. And we knew that we wanted to bring people in. And so as a team, we created a system for our working group that basically says everyone is welcome. If you want to join the working group to get involved to, I don't know, help out with making our docs site better, or you have a very clear idea of how Tauri should work on Android, or you have a great time just helping people answer questions, we're always open. And because of our security policy for cutting new releases and the way we review all of the code, we really prefer the tofu approach, trust on first use. You come, you want to get involved, you're absolutely welcome to. And I think that that's a model that really grew out of, off the heels of free and libre open source software, where that community came from was, yeah, we can do this together and we want to do it together. So we don't raise the bar to make it difficult. There's no, tests. Just show up and say, hey, I want to help. And in order to take that kind of one step further with our community, we joined the Commons Conservancy. So the entire code base is owned by a foundation in the Netherlands. So it's the Tauri program within the Commons Conservancy. That's our SPDX claim on all the files, in all of the repos. And the reason why this is important is because as the project has grown, we wanted to not only address the very real concerns of maintainership burnout, but also hostile takeovers and the ability for funding to come in and change the project in ways we didn't want it to change. And that's why there is no open core model. Everything is open. Everything is dual licensed MIT, Apache 2.0, and it's always going to stay that way. Now, we also have an open collective. We've been collecting funds to pay for the audit. You're welcome to donate there. The thing that we've noticed is that some companies started to donate, which is great. And some developers started to donate, which is great. But we sort of feel like the open source community needs to come together and figure out a way to turn open source, the free part of open source, into something other than free real estate. That's this kind of ideological model of open source that's sort of been, crushing us for such a long time as a community. And it's why people burn out, and it's why people only do open source on weekends and nights. And I think that that's something that we can all address and work toward changing. Now, I've talked a lot about kind of the high level stuff. So I'm going to come down a couple thousand feet and talk about the pieces that make up Tauri. And so we built a number of Rust crates. I alluded at the beginning to the way in which we were interacting with the WebView community via the project from zSerge. And what we discovered there was we were constantly using multiple language paradigms in order to address different operating systems. And so we sort of went back to basics. And I mean, actually, the first thing we built was Rye, the WebView rendering library that injects it into a window. But we needed to create a window. And we were using at first the amazing Winit project. But at a certain point, our approach needed to diverge because we needed to, not just make windows, but add menus and a system tray and keyboard accelerators. And there was really no great way to do that with, I'm not going to get into the details of who owns the loop, but we needed to make sure that the application at its root was, responsible for menuing, system traying, and accelerators. So we forked Winit, and it was sort of with a heavy heart, but we're working toward modularizing the things that we've added to Winit to call it Tau, so that it can potentially be reabsorbed back upstream by Winit. So again, Tau is our windowing agent, and Rye provides the WebView interface to, well, at the moment we have a stable Windows WebView interface. We have a stable Mac OS WebView interface, and Linux is also stable. So basically we're using WebView 2. A big, huge shout out to Bill Wavery from Microsoft for helping us integrate with Windows RS. It was amazing to also see him constantly come back and helping us update. Shows that the community is very, very strong. We're using WK WebKit on Mac OS, which is the WebView provided by Mac. I think it also has room for improvement, and we're looking forward to engaging with that community as time goes on and continuing our engagement. And for Linux, we're using WebKit GTK. And WebKit GTK is also a special case, but the fun doesn't really stop there because, on Windows and Mac, you always really know more or less what's serving up your window. But on Linux, there's a variety of things you have to contend with, whether it's X server, or if you're using GNOME, or the matrix of possibilities on Linux really makes that system into a whole number of unique edge cases that we're still working on. So anyone out there really interested in getting involved, I think that Linux is the family where a lot of attention could be spent, especially with regard to packaging. But that's Tauri. So Tauri takes the Tau and the Win libraries and adds APIs, application structure, and build tooling into the mix. And so with the APIs, what you end up getting are things you can call from, low-level system interfaces that you can call from Rust or from JavaScript in the user interface. And so, we've provided interfaces to classical things like the file system and, the dialogue for where do you open or save a file. And we also offer an interface to, spawn a shell and run a command in a shell. And all of these APIs are protected by an accept list. So basically what that means in your configuration file, you then determine which parts of the JavaScript system and which parts of the Rust system you want to use in your final binary. And, it's one of those twofers. Well, on the one hand, you have a smaller binary size, and on the second hand, you have a smaller attack surface area, and instead of, placing the entire V8 engine inside of your application, you're only placing the exact things that you need. I'm preaching to the choir. I think everybody here understands that. And with our build tooling, we obviously provide a CLI that allows you to create a new project, to create a dev server that allows you to interact with the application as you're working on it, and also a build pipeline. And so what this means is that Tauri kind of brings all of the pieces together, and at the same time, it might not be something for everyone. And as a matter of fact, members of several of their communities have started using Tau and Rai in their own projects, notably Dinosaur, who's doing a wonderful integration of Rai so that they can build desktop applications. And they take care of the rest of the bundling on their side. And it just goes to show that there's a lot of possibilities out there. And by modularizing your libraries, you can make them accessible to people who might not want the whole kitchen sink, right? So I'll just briefly talk about a couple of the features that the Tauri project brings. So first and foremost on everyone's mind here is, do I have to install Node.js? You don't. The entire CLI is actually built in Rust. We have a Node.js wrapper that you can use if you're a yarn/npm/pnpm user, which is totally acceptable. Most of the frameworks out there, front-end frameworks that is, are still attached to the Node.js ecosystem. This is changing a little bit, with projects like Dominator and Vue. And potentially in the near future with Svelte. We'll see how that goes. And so other features, and I talk about this a lot, menu system tray accelerators, but actually that's kind of the stuff that you expect, right? An application on your device should have a menu, should have edit, copy, paste, quit. If you want a system tray, there should absolutely be a system tray with an icon that you can update. And if you press Control Q, then it should, if that's what you want to do, quit the application. It should quit the application. We also offer multi-window systems. One common use case for this is to spin up a transparent splash screen while the bulk of your application is loading. But you can also make a sort of headless application that just lives in the system tray. There's also a lot of use cases for that. And we've even seen some Jenkins, that's not the name, some Jarvis, I forget the name, but this type of Spotlight application where you can highlight some word and then press a key combo and a web view will pop up exactly at that location. And just a little small strip, and it's basically what you would expect as an application designer, and we try really hard to maintain those conventions. And of course, there's other things like system notifications, but also in-app notifications, and then we have the updater. And this is something that always felt a little bit bolted on for other systems, and so we built an updater service, learning the lessons from other frameworks. And I'll get to the updater in a second. We have a couple announcements for you all here today. And obviously there's also dev tools. So in the web view, you can hook into the JavaScript console. You can step through, you can analyze the traffic, the memory consumption, basically everything you would expect from a modern HTML, JavaScript, CSS renderer. We also provide a secure context without strong arming you into using a local host web server. And it's sort of low key, I think, but it's one of the things that we're very proud of. And that is in isolation type projects, in greenfield projects where you get to design how you do everything. Just because you're using HTML, CSS, and JS for the user interface doesn't mean you have to comply with the rest of what HTML is. If you want to use the noise protocol to communicate with your remote service or with the backend core, you can do that. And we don't open up some random port on your computer over HTTP. So there's no clobbering and also no listening. So your application is, again, smaller and has less attack surface. Like I said, we provide macOS, Windows, and Linux. And we have a GitHub action for building all platforms. We're working on a GitLab version of that, but it's complicated. I'm not going to talk about that today. It's future. And it works with all web frameworks. I will mention one key thing. I'm not good at calling people out. But in this case, I think a commendation is definitely in order. If you're familiar with JavaScript, there's a thing called the object prototype. And you can, as a developer, modify that prototype. As a hacker, it's great stuff. It's really fun to modify the prototype. And one of the security features that we are offering in 1.0 is the ability to freeze that prototype, which means that people that you probably don't want messing around with the prototype can't. There is one framework out there that we've noticed works fine if you freeze the prototype, and that is Svelte. If you don't know Svelte, big thumbs up to that team. Amazing crew, wonderful, wonderful build system, tiny binaries, logical, or not binaries, but tiny blobs that you render out, and super performant, easy to understand, great to use, highly recommended, and you can freeze the object prototype. Many of the other larger, older frameworks, I'm not going to name anybody, but they play around with the prototype, which should scare you. Anyway, the near future, the fully audited and stable 1.0, that's coming in the next week or two, maybe 3, but we're already at a number of RCs for this big release, and it has been audited. The auditors have approved it. They're still keeping a watchful eye over us. And this is sort of the semi-biggish announcement. If you are running a open source project on GitHub, we've partnered with a pretty large company out there called Cloudflare, who are providing the Tauri organization unlimited workers. And what that means is, using our updater service, when we launch this with the 1.0 stable, you will get free, globally distributed updates to all of the app users, no matter where they are, which is really great. It means you don't have to tool it yourself. It's been audited by our friends at Radically Open Security, and it's an easy, low friction way for your project to get out there, and it will ultimately save you time and effort. So mobile apps are coming. We already have proofs of concept for Android and iOS. They're both obviously differently complicated. We hope to get those out for the 2.0, which we're slating for end of year. But obviously, there's a lot of engineering work that goes into it, and we also need to have it audited. Cross compilation, by the way, again, hats off to Mr. Wavery. Seems to be working. We're in the throes of making sure it is stable and solid, and if all goes well, it'll come out as a recipe for the 1.0. We're working also on security tooling, which, as I mentioned earlier, is something we want you to be able to use in order to have a sense of security in what you're building, and we'll give you warnings if we think, hey, the CLI just performed a static analysis on your project, and we discovered that you're importing everything from the API, but you're only using 2 of them. Maybe you want to prune that down. Then the elephant in the room, bindings to other languages. Why would anyone ever want to use a different language, you ask? Rust is perfect. We're not maximalists. We come from a place where we recognize that every developer might want to do things their own way. They might use C#, they might want to use Dino, they might want to use Java, they might want to use Python. And our plan is, after the 1.0 launches, to create bindings to the core functionality of Tauri so that, instead of merely creating a sidecar, you can actually rig and run an entire Tauri application from the comfort of Emacs and Common Lisp, if that's your thing. So next up, WebRTC. It already works on Windows and Mac, but obviously if you do not compile WebKit GTK yourself, you're not going to get WebRTC. And since that's something that nobody's doing right now, it's not technically available. We are working with Agalia to push this forward. And big shout out to the GStreamer team. Amazing. If you haven't heard of GStreamer, then go back to crawling under your rock, because that project has been around forever and it's still kicking. Next up, GL Windows. We're working on a proof of concept with EGUI. If you haven't heard of it, awesome project. It is fantastic, and we hope to be releasing an update later this summer where that's been integrated and available. It might only be on the next branch because it hasn't been audited. Obviously, you know us. We only want you to be safe. If you're able to audit it yourselves and you think it's safe, then I'm sure it's okay to use in production, but we like to have those guarantees. And so the final thing here is the books. Books, you say, well, yes, Lucas and I are putting together a book called Tauri Foundations. And it wasn't planned that this talk is the day we announce it, but we're ready to announce it. And I thought might as well give a ray of hope out there for all of our supporters who have so kindly donated to help us get to where we are now. Tauri Foundations is going to talk about, obviously, security, open source, and the guts and innards of what makes a Tauri app. It's not going to be the codex. That's coming out later this year. It'll be a much bigger volume where we go into every teeny tiny corner of Tauri. But this book will be coming out in the next several months. There's a link down there. I think that's where you can find it online. Thanks to our publisher, Pact. We're really looking forward to it. And thank you. I really warmly encourage you to unstar Tauri apps and star it again just to get to the top of the list, or you can follow us at Twitter at Tauri apps. If you need to reach out to me personally, I encourage you to send an email. There's my email right there. And yeah, that's it. That's all I have for you. I think it's that's it.
Very nice. Thank you very much, Daniel. It was an awesome talk. It was super interesting. I have to admit that I haven't tried Tauri yet, but I will as soon as I get I find a few minutes left. I definitely will. And so does people in the chat. Take a look at the comments that we see here. For instance, Dominic was saying he was considering Electron, but now he will definitely check out Tauri.
There are people who have actually built I believe it's for OBS, a live translation overlay. It's amazing. I mean, absolutely highly recommended. Stop by our Discord server if you get stuck. We're always happy to help.
Mm-hmm. Very interesting. Thank you. Thank you very much. People, if you have any questions, keep them coming. We see a lot of, wow, great, I tried it, it was very good, and I will definitely give it a try. I didn't have any questions come up yet.
Well, I have one last comment that didn't really make it into the slide, and that is, we've been working for about 3 years on this project, and it's always been our absolute imperative that the system is solid and stable and works. And we know that during the beta phase, there's been problems, especially with people who are new to the Rust ecosystem and are like, cargo what? And seriously, it takes 30 seconds to build. I want you guys to know and maybe spread the word. If you tried out Tauri a couple of years ago and you weren't happy with it, let us know. We're always working really hard on improving this, especially for people who are new to the Rust side of things, the Rust way of working. And our deep intent is to produce a sort of a bootstrapping CLI where it will detect what you've got installed, what kind of system you're on, and then install all of the stuff that you need. Every platform is different, and Linux, I'm looking at you for being the differentest, but we love you. Yeah, so that's it.
Thank you very much. Super interesting. I just took some comments from the chat that we had, and I displayed it on the screen. So you got a lot of applause here for this great project. Thank you very much for the great work you do. The community really appreciates that, and I personally find your approaches to security and also thinking about environmental consequences of what we do as developers super refreshing and very inspiring. So thank you about that.
Thank you.
We have one question. Maybe we can close with that one. How much knowledge in Rust does a person need to actually be able to make a decent app with Tauri? Would you say advanced, or what level would you consider somebody to need to have?
I guess the question is, what do you mean by decent? When you're giving talks, it's really important that you envision your audience being naked, and I'm sure all of you are naked at home right now, so that doesn't work. By decent, I assume you mean something robust that allows you to interact with the file system, maybe, and potentially talk to a remote service. And to be honest, for 90% of the applications out there, you can just use the JavaScript API that we provide. And okay, you might have to edit a little bit of JSON, but that's pretty easy. And you might have to learn a couple new commands like cargo Tauri build, but the barrier to entry is really low. However, if you are an advanced user and you say, I don't know, you want to do some kind of crazy encryption in the Rust core, well, then you just bind in your library, and we have a complete plugin system that allows you to not only expose all of the functionality of that library to the Rust core, but you can also create and ingest the JavaScript API endpoints so that you can really do that crazy encryption stuff in Rust where it's obviously safer and faster, and then just display the results. Maybe it's just your signature or something, or the encrypted blob. It's a nice system, because what we've found is that absolute beginners who maybe never even used the web or Rust are able to take one of our Create Tauri app templates and start, hit the ground running with Svelte. And there's tutorials out there for all of the front-end frameworks, and we try to make the APIs easy to use. And so what that ultimately does is grow. Like, we found that Rust grows on people. I don't follow people on Discord like that. I'm not a stalker or anything, but it's really heartwarming to see people come to our project and say, this is weird. And we're like, no, it's easy. Just do it this way. And then literally months later, they come back and they start fighting for the thing that they were against at the beginning. And I mean, okay, we all cut our teeth on Rustlings. I did. Like, that's how I got more confident in Rust. But what we're seeing is that by doing all of this scaffolding with the Tauri CLI, it's a lot easier to get something working in Rust. And that first aha moment is a really great thing to have for people.
Mm-hmm. Super interesting. I teach 1 day a week at a vocational college here in Austria, and I think I will try that. And I think I will give a homework to my students so they can try packaging up their web development work into Tauri, into a Tauri app. And I will send you some feedback if we have some interesting feedback. So I would like to close by joining Zella Relum here with his comment. Thanks a lot for the talk. I would second that. It was awesome. Thank you for being here. Thank you for being part of the community here at the Rust Meetup Linz. Daniel, I know that you have a follow-up meeting today, and we're already a little bit over the time that you said that you have. So thank you for being here, and many greetings to Malta. Stay healthy, stay safe, and we hope that you will join us in the future at maybe another Rust Meetup Linz.
Maybe I'll see you at the Rs. Ciao.
That would be nice. Bye. And with that, we come to our second speaker of the day. And I think we are perfectly in time. And I see Sijan is already here. Hi, Sijan.
Hello. Can you hear me?
Yes, we can hear you and we can see you. And that's fine. Very, very good. So what do you think? Wasn't it a great talk from Daniel?
Yeah. Quite a lot of info.
Very interesting. And I see Stefan is already here.
So now you can hear me. Hi. Sorry, I'm having huge internet troubles right now. But I hope I'm okay. And
yes,
you can hear me. Sorry, just kidding. Hi, Sijan.
Yeah, hi. How's it going?
Sijan,
I don't know how to pronounce your nickname though. Did it?
That's Parrot. So
That's
if you've ever watched Monty Python, that's what my Twitter handle is about, and it's the worst one in the world. But
yeah, like 1,000 times. That sketch. I keep showing it to people who are not familiar with Monty Python.
So you know what that parent means. I must admit I have never seen the film, but I have to, so I understand it.
I actually had it a picture of that in one of my blog posts once.
Oh, cool!
Right. So you have something in common. Very good.
Fantastic.
So, Sijan, we are looking forward to your talk. I asked Daniel the question, and I always ask our guest speakers because we have quite an international speaker crowd here. Where are you broadcasting from? Where are you located?
I'm located in Berlin, Germany.
The city of Rust, isn't it?
Yeah. Right now, yeah, it seems so.
I think it's one of the most active communities regarding to Rust in Europe. I see a lot of things going on, a lot of projects be located there, companies who focus on Rust, a great city for a Rust developer to live in.
Yeah, I think so too. And also it's like, just in general, like new technologies, they just find their way here first before they go other places.
Mm-hmm. And Sijan, your talk will be about runtime-agnostic async crates. We are looking forward to that, and I think we are nearly exactly on the planned time. So we will not stay in your way any longer. The stage is yours. Sijan, do you want to share your screen with us so we can put your slides up?
Make the attempt. Yeah, I'm on Linux, as Daniel was saying that, Linux is not like.
But we tried it before, so I'm pretty.
Yeah, it worked previously.
That it will work.
If it works, we should thank the Pipewire folks.
So
the only thing is I have to do it twice. Like last time, it was the same.
Okay.
Oh, now we can see something. Yeah.
Now we can see something.
Great.
But no, it doesn't work yet. I think last time you had.
Now it is. Yeah, you have to switch to the window, and then it works.
I see.
All right. So everything clear? Like text is good?
text is fine. We can read everything. We can hear you. We can see you. And I think we are ready to go. And we are looking forward to your talk. Zishan, thank you for being here. The stage is yours.
Thank you so much. Hello. So welcome to my talk. I'll be talking about writing runtime-agnostic async libraries, and if it's even possible. And if it is, then how exactly? Let's get into it. First of all, who am I? As I was introduced, my name is Zishan, and I live in Berlin. And I'm from, I'm a bit of a nomad. I've lived in many countries, and originally from Pakistan, lived in Finland for 8 years, in UK for 3, in Sweden for 1 year, and now I think 5 years now I've been in Berlin almost. So yeah, it seems that I'll be staying here for long, but let's see how life goes. And I'm a freelance software engineer. The funny thing is that Daniel mentioned GStreamer, and that's the first project I got into. Actually, I wasn't even out of my uni yet, and I got into it, and it was like 2001, the beginning of that project even, and I was one of the first users, and I made a video wall out of it. So my background is more like systems programming, and I've also been involved very much in GNOME, that was also mentioned. But recently I've been more into cloud and now web backends in Rust. And for the last 4 or 5 years, I've been super into Rust. And yeah, as I said, mostly I have a background in free and open source software. These are my passions and likes. I'm into flying. I have flying licenses, and I have 3 cats. So about the talk, a bit of background first before I dive into it, because this is a bit complicated subject, and I'm not sure most audiences have even used async much in Rust, async await. So what is it about async await in Rust? It's like a normal flow of program, right? Like when you write synchronous or as I would call it, blocking code. Instead of that, you declare your function to be async, and then you from another function which has to be also async, you await for that async function, and that's what async await, like very basic thing is about that. And in here we are lying about reading a file, but we will add an actual implementation of this function later. But for now we're just lying, and we have this code, and what we do is we just run like the function from main, and it builds. There's a warning, but it builds, and it also runs fine. There's no runtime warning or error or anything. But that function that was printing something, that wouldn't actually print anything when you run this code. And why not? If you are coming from another programming language where you have experienced async programming, this would be very surprising for you, because in other programming languages, it will actually print something. And the warning you get when you build, it gives you a hint. Actually, it tells you exactly what's wrong with it. And the reason is that when you call an async function, it doesn't actually run the code in the function actually. It only returns you a future, something called a future, and that future needs to be awaited. It doesn't. It's the future. Like what does it even mean, right? And it's these functions are returning something called a future, right? It's a type in a standard library, and yeah, but I've always dreamed of seeing the future. What is a future anyway? And the future is a very simple trait. It has an output, just like a normal function, right? Functions usually have an output, and this has one method only, and that's pull. It's a bit scary when you look at it, but it's actually not that scary in the end if you know what's it about. It only has 2 parameters, right? But the main point here is that it has a pull, and you have to pull it. You have to call this function, and so when you in Rust, what it does is like when you have an async function, it translates it into this. So the async is removed from the function, and the return value becomes ample future, and the output of that future is what you declared the output of the function to be, right? And futures, these futures are inert in Rust. They don't run on their own until you explicitly run them somehow. Future needs polling, and that, as you saw, there was a poll method, and you need to continuously call that until it yields a value, because the main point of async programming is that you use it for example, for I/O and stuff like that, where the result might not be immediately available, so you might need to wait for it. And instead of blocking on that, you can say that I want to await it, and that's why it needs to be polled. And the poll function, when it's ready, when the result is actually ready, it's supposed to be, that implementation is supposed to return it finally. And that is done by something called runtimes, which is what this talk is about. You cannot directly call poll on the future. Well, you can, but you will have to implement a mini runtime on your own if you want to do that, because it's designed to be called by runtimes themselves. And we don't have built-in runtime in Rust, which is why we have a bunch of runtimes out there, and they're quite incompatible. And that's why there is a problem, and that's why there's a need for me to talk about this subject. And the most famous one are Tokyo and async STD. But there are many others for different purposes. There are some that are very specific use case. They're designed for very specific use cases. Some are more generic, like Tokyo and async STD are very generic ones. And what do these runtimes actually do, right? Like how do you consume those futures or run those async functions that you declared previously to completion? You need some kind of entry point. And that's why you have two entry points usually provided by almost all of these runtimes. One of them is blocking on it, and there's a function provided for that. And then there is API provided for spawning tasks. And we will have a look at each one of them separately. First of all, it's blocking. And that just means you turn an async into a synchronous blocking call. And you can have like a series of async calls, and one async call waiting on another by calling that function and calling .await on it, and then vice versa. And there could be a huge chain of that, and typically there is in async programs. And then in the end, you say, okay, I want to block on all of this together, and then you do something like this. This is an async example, async STD example, but Tokyo provides a very similar API for blocking on, and all of them do. Like there is a block on method, I think, in almost all runtimes, exactly the same name. And there are main wrappers provided as well, so you don't want to do block on. They provide attribute macros where you are able to declare your main function as async. Then the Rust by default doesn't provide it out of the box, so the runtimes provide this. And also because you need a runtime to make it happen, and Rust cannot assume a specific runtime. So that's why it can't be there, at least right now. And then there's spawning. Spawning is actually like how futures and async works in other programming languages usually, which is when you call something, an async function, it starts running on its own. And in Rust, you have something called spawning a task, a concept like that, where you say, I want to start it now, this async block or function, and it will just spawn it immediately. It depends a bit. So tasks in async world is very similar to threads in the synchronous world, except that task could be threads in multi-threaded runtimes, but it doesn't necessarily have to be. There are single-threaded runtimes as well, And in the same runtimes, there's options to use whichever you want to use for your use case. So yeah, it could be threads, it could be not threads. But they're similar in the concept, because you spawn them and then you can wait on them. You can you can wait for them to finish, just like you do with threads. So that's what we are doing here, like just spawning 2 tasks and then just giving them time to finish. So runtime agnostic libraries, right? That's what you came here for. I have to say that you might be disappointed with my talk, and it's not. I don't have a lot of good news. There's a lot of bad news and some good news here. So be prepared. And the reason I'm doing this is because I have been maintaining and developing a library called Zebus, which is an IPC library. And the main point of that, because it's an IPC library, the main thing is I/O. And this is where you really need async. You really want async. And our first version, Zebus 1.0, was fully synchronous. We added some async bits later, but it wasn't really async. And with 2.0, it's now primarily async, actually. With the synchronous parts are now just wrappers around the async, actually. So I got bumped into all these issues that are there because of having different kinds of runtimes and them being incompatible. So I decided that maybe I should share the knowledge I gained from that time, and it will be useful for others, I hope. So read from file, right? The code I shared before that I didn't implement, actually. Let's implement that. Let's assume it's part of our new library, which needs to be asynchronous because it's reading from a file, so it's I/O. But it could be a socket, it could be anything. And let's do it. So how do we do it? We need some kind of async API to read files, and one of the APIs would be, I guess, Tokyo, right? And the async stud provides something similar, most likely the same. I haven't checked, actually, but I checked it a while ago, but I don't remember. But yeah, it's very similar. So we choose Tokyo for this one, right? And we use the file open, just like you would do in synchronous code. Just the difference is that you would await it, and your function is async now. And this does the job. And client code works just fine. Client code just calls it and waits for it in their async main. All good. But what if the client doesn't use Tokyo? What then? So they will do something like this. It's almost the same code, just that you have async stud main instead of Tokyo main, right? It will build just fine, actually. But at runtime, you will get this warning, or actually error, because it's a panic. There is no reactor running. And the reason is Tokyo APIs assume a Tokyo runtime. By the way, probably you saw it's talking about reactor, not runtime. There is a subtle difference between reactor, runtime, and there's another term. But for the sake of this conversation, they're very similar, and they're used interchangeably, actually. So let's not do it. The other one is executor. So executor is something very similar, but it's used interchangeably. So we will do the same for simplicity here. So yeah, it resumes a runtime, so we can't do that. And the other problem that you will have when you write async libraries, right? You will need to spawn tasks. You don't want to always wait on something. I'll give you examples. Let's say you need some background chores. An example of that would be, for example, in Zebus, we had to have we have a connection which is backed by a socket, and we can have multiple, maybe hundreds, maybe even thousands of streams that need to read at the same time from the same socket. How do we do that? How do we accomplish that? We tried different ways, including locks and stuff, but that's really, really messy, and it can easily deadlock. Like we had so many deadlocks developing that code. Ultimately, I gave up and went for other approaches. And in the end, we ended up with this approach where we have a broadcast channel, and the sender is just receiving from the socket. It has only access to the socket itself, and all these streams are just receiving on that broadcast channel. So each time something comes on the socket that the sender, the broadcast sender, sends it to all the streams. But how does it work? Someone has to be there. Someone has to be reading the socket. Who is the sender? What is the sender? So there has to be a thread, right, or some task. If it's a task, which runtime would it be in? Like we are assuming no runtimes, remember, or at least we want to not assume any runtime. So how do we accomplish this? So that's another problem. And another very related problem is async callbacks, or any kind of user code that user gives it to you when you have to run. It doesn't have to be necessarily callbacks. There's other examples of that. If it's async, how do you wait for it? As I said, you need a runtime for waiting on async to execute the future till completion. So how would you possibly do that without assuming a runtime? Solutions? No perfect solution. I've warned you, you will be disappointed. And I'm sorry, there isn't any. I tried very hard to find one. There isn't. The first solution that comes to people's mind, and a lot of people went for that, is to give in to Tokio. And there are some pros to that. Definitely compatible with majority of your apps. Most apps out there, as far as I know, use Tokio. And if I'm not mistaken, it's increasing, the number of apps using it. So if you just want to be compatible with most apps and you want to make them happy, it's the easy way out. You just do it and just, but then you have to be okay with the cons, which is you're requiring Tokio. It's not like Tokio is always possible to use for the apps. There is many use cases where Tokio, at least right now, would not fit. It's a very generic runtime. It's a very generic API, and it's very good at that. But for specific use cases, let's say you want to do something for embedded systems where you have very limited resources. You would ideally want something that doesn't even allocate, or at least it doesn't assume STD library. So you can't use Tokio there because currently it doesn't support no-std, and even if it did, it doesn't support no alloc at least. So that would be one example, but I'm sure there are other examples where it's just not feasible. So you need to be okay with that. For those use cases, your API would not be useful. As I said, it's not always possible. The second approach, which I started with in Zebus in the beginning, was use runtime-agnostic crates, and there are some out there. And for example, the primary one that we used, and also I somehow ended up becoming the maintainer, well, one of the many maintainers of it, is a project called Small RS. It's also a runtime, a very small runtime, but it's more like a runtime kit. So it's divided into small, very, very small subcrates that make it up, and they provide different functionalities. Like for I/O, you would use async I/O. For channels, you would do async channel broadcast, async broadcast, and stuff like that. I'll go through with some of these in a bit, and some of them are truly like they're agnostic to runtime. They don't have to do anything weird to do that. Like async channel, async broadcast, especially there, they don't assume anything. The others don't, but as well, actually. But there's some cons. I'll talk about it in a bit. So the pros, you will be async runtime agnostic mostly there's a one small thing that I'll talk about later, but mostly you are compatible, so you're good. And then cons, yeah, it has to launch threads, at least some of those, and one of them is async IO, and the reason is, if you remember, I showed you the future trait, the poll method. It also gets like a context. So as I said, runtime calls the poll continuously until the future is resolved. But it doesn't busy loop. It doesn't keep calling it in a loop. It calls it only when it's ready. And how does it know when it's ready? There is in the context that's passed, there is also a waker. So the runtime gives a way to the future implementation to call it back when it's ready. And so how would that be accomplished? And the main way is to use threads. And async IO is no exception. It launches a thread to monitor that those sockets or whatever is behind the future, and wakes up the runtime that, hey, I'm ready now. But you have an hour thread running behind your back, at least one. And then another thing is async executor. What this does is that you have a small, really tiny runtime if you use it inside of your library, like Zebus does. And how we use it is we all the chores that I mentioned that we have to do inside the library, and all the user callbacks that we need to call, they are done as a task on this executor. And this executor, of course, someone needs to run it, right? Someone needs to, it's called ticking. Someone needs to tick it. How would you accomplish that without having a runtime, right? Where would you run the task that runs these tasks of this executor? So that's a bit of a problem, but this you can accomplish with threads. This is how we did it in Zebus, and you can of course also do it. So by default, we run a thread that runs this ticks this executor. But you don't necessarily need threads, actually. What you can provide is, like we do in Zebus, this is a Zebus example, is like we have a connection builder that creates the connection, but at the same time, you can tell it to disable the internal thread that we were going to launch for you. And then once you have the connection, what you can do is run that with your own runtime, like whether in this case it's Tokyo, but it could be any runtime, and you can spawn a task, and then you can just execute, tick the executor. And as you can see, that itself is also async, so it's perfect for running in a loop inside a task in your runtime. But as I said, it's still not 100% compatible with Tokyo, and the main thing is the user code that you need to run. Because if there is no Tokyo runtime running, and then you call something that is a Tokyo API, it will assume a Tokyo runtime, and it will fail because there is no Tokyo runtime running. But if you do it like we are doing here, of course there is then a Tokyo runtime running everything, so it will be okay. But that assumes that there is from outside you do this yourself, which is a bit of manual work. It's not a lot of work, as you can see, but still it's on you as a user to do this, and users can't be expected to remember this, right? So yeah, it's not out of the box working. So another compromise that we ended up in Zebus in the end was to do both. And what does it mean by that? It's you use feature cargo features, and you by default you use something like async IO. But people should be able to disable that, as like when you can disable default features, and then you enable Tokyo feature. And once you do that internally, we can handle it. Like we use the Tokyo APIs everywhere for everything. If you do that, if you disable async IO and enable Tokyo, And if you don't, then we use the async IO and launch threads. So because we have to, there's no other way. But now user has a very easy way of accomplishing, like if they are using Tokyo and don't want to bother with anything, they can now do that. And yeah, they don't have to care. And the pros of this is, user doesn't need to do much at all. Just declare it right in the cargo toml, and that's it. And the cons, it really complicates the library code, right? Let me show you an example. This is just like a small part, like of the code that we had to do, and we had to write in Zebus. You need to have a lot of these CFGs in the code. Well, we ended up with not as many as I thought we would, but still, it's a lot more than I would want. I've heard there's now crates that actually abstract this. I haven't tried those. Maybe I will have a look at those, and which abstracts different runtimes for you, and you can just enable whichever you need, and then you don't have to do it in your code, but that crate does it for you. But I don't know. I wouldn't vouch for it because I haven't tried. But have a look. So yeah, that I'm sure that makes you sad with what you can possibly do, but that's how it is. I'm sorry, but there is some hope. There is an async working group for a while now, for many months, half a year I think, and I was actually in the beginning part of that. And provided as much feedback as I could, and make sure that the people who are actually working on that stuff to make it better, the async parts of Rust, they know all the problems that exist, and they have proposals. They have ideas of how to improve things. I'm not sure how much would they be able to achieve, but because it needs a lot of collaboration with the runtime folks, right, the maintainers and stuff, and they might not have the same priorities as the async working group or the upstream. So I'm not sure how far it would go, but I'm pretty sure it will go far enough that it will not be as horrible as it is right now when you want to be async runtime agnostic. There's ideas for creating some traits and abstractions in general for different runtimes in the standard library. So that you can have some generic API that you don't need to assume a specific runtime to do specific things. So yeah, we're looking forward to that once that's there. So there's some hope. Don't worry too much. And that's all.
Thank you very much, Sijam. It was super interesting, and I have to bring Stefan on the stage because from us two, Stefan is the Tokyo async whatever guy. So I guess Stefan took a look at your talk, and I think, you might have some questions. We will see. We have one question maybe from the audience. Let's put that one at the beginning. Is it okay for you, Stefan?
Sure.
And this one here. Why does the calling function of the async function also have to be async? That was quite at the beginning of your talk. I think when you did, by the way, great introduction for those of you who are rather new with Rust regarding futures and so on. Maybe you can elaborate on that a little bit?
Sure thing. So as I mentioned, so you either have to call an async function from an async function, and then you can await it, right? Or there's an alternative, and that's to invoke a runtime and tell it to either spawn it in a task or block on it, and that which turns it into a blocking function, async function into a blocking function. And the reason you need to do it is because the way async works, right? Like you need to poll it, and the only way to poll it is either you postpone it, and the way you do it is call it from another async function, and then that function also implements a future, right? And that future can be polled in turn, and then there's a chain of polling going on. So that's the reason You need to either dot await it in an async context or async function, or you block on it, or you spawn it in a task. And one thing I probably didn't mention was that task itself also implements a future. So you can launch a task and then later wait for it to finish its work in an async context. So yeah. Does that answer the question?
I think so. I think so. Yeah. I have a question, kind of follow up. I come from a strong C# background, doing a lot of work with tasks in C#. And there on Windows, they use a quite efficient mechanism which is called I/O completion ports to do async I/O. Do you happen to know whether this is also used in Rust?
I'm not familiar with that, unfortunately.
Okay.
But what I can tell you is that like different runtimes, that actually was one of the reasons to keep runtimes out of async thread, right? Because runtimes are very opinionated. They have to be. So they run. They have different methodologies. Some will use thread pools to make efficient use of threads and launch multiple threads, and some will not use threads at all, but use green threads and do it with one CPU thread. So yeah, there's different strategies. So I'm sure what you're talking about is some runtime is using that, because there's so many strategies deployed by runtimes already in Rust.
Okay.
And also there's I know people who are very much involved with async ecosystem in Rust. They come from C# background. So yeah, I think probably most likely.
It will be an interesting time. I can tell you, coming from a C# background, and I know a lot of developers in this area, you are pretty much used to that such low-level things are baked into the platform, and it's a little bit of a shock for people coming from C# to the Rust world to learn that not even the async runtime is something that you can take for granted. I fully understand that it has a lot of value having choices, absolutely.
Mhm.
But as a platform, I think we have to ask ourselves, what are the costs, what are downsides? There are downsides to that when we
Right.
want to bring people to our platform. But I'm not saying that I don't want choices. So it's a two-sided sword, and I'm not 100% sure where I am.
Right. No, I that definitely there is many pros of having the runtime in the library, in the standard library, as part of the languages even.
Mhm.
But there is some cons too. So there's a bit of middle ground, I guess. I come from, as I said, system programming background, so from C. So I'm used to much worse pain than this. And
Gotcha.
so to me, this is heaven.
Cool.
Very nice, very nice. Zishan, I think that was a great closing word. World has become much better even for low-level system developers. I really enjoyed your talk. I really
Thank you so
enjoyed
much.
it. I learned a lot. I am familiar with some of the concepts, but it was really very well structured, and you gave a great talk. Thank you very much.
Thank you so much. It's
Thank you.
just like it's a complicated topic, so it was really hard to squeeze it in the short amount of time we had.
Absolutely, but
so I hope that I did manage to explain some things at least.
Absolutely, I'm absolutely sure, and I'm looking forward that Stefan, you can edit the videos and put them on YouTube, because I think that is
Absolutely.
a reference for people who come to the Rust world and are not taking all these discussions about runtimes and so on for granted. And with your talk, they get a little bit more background information why the world in Rust is as it is.
I'm pretty sure there's going to be a reference video. Absolutely.
Yeah.
Cool.
Yeah.
Cool.
Thank you,
Glad to be
Zishan.
on.
Thank you. Greetings to Berlin, and I hope we will meet each other virtually or physically in the near future. Zishan, bye.
Thank you. Bye.
Bye. Stefan, I think that's it. We are
That's it for
through
today.
with
Yeah.
Rust Linz Meetup 19th. Next time we will have the 20th edition. We have a kind of birthday, not really birthday, kind of whatever, special meetup. maybe people are interested. We already have some plans for guest
Mhm.
speakers.
It will be in exact 1 month, I guess, March 24. I guess this is the
that's
date
true.
we proposed, yeah. And we have,
Exactly.
we need to check back with them, but we already are in contact with a couple of speakers who might speak.
Yeah,
next time.
absolutely. Will be exciting. There are only preliminary okays from them, but we will do our very best to have a great guest speaker lineup for next month. Any final words, Stefan, for today's meetup?
No, not from my side. Thank you, everyone, for joining us today. I have one final thing, because I always forget to do it, and I really like it. Everybody who's in the chat right now, take out your clapping hand emoji and give a round of virtual clapping hand applause for all our speakers today, and for our sponsors, and for everybody who contributed today. And this always takes a little time until we see it in the chat, and there it is. So yeah,
Exactly.
thank you everyone for joining, and thank you for being with us.
Bye. See you next month.